Here are a few tips, and again, it's really general ideas that you can look into. So the first thing before starting to shoot anything is to do some pre-production and planning. So why are you doing your video? What is your angle? Is it to be visible to users, or to demonstrate achievements, or to demonstrate unique expertise? And who will watch the video? Is it for the users or for the general public? You definitely don't have the same presentation depending on your target audience. Is it for your administration, so that they understand what you're doing? Or is it for fellow imaging scientists? In that case, you can become a lot more technical. And also you need to hold your audience. So you need to lead with awesome, show enthusiasm, and have a story. And again, maybe I should have added the pointed, not too long on that slide. So in terms of technicalities, some tips to make good videos. So first, the camera. If you can use a good camera and fill the space, that's a good idea. And don't be at the bottom on the screen or very small or in the background. If possible, get help. We could see in the QCP video that having some support, someone filming, can really add to the dynamics of the video. And be creative, have shots taken in different places. For the light, make sure you have good lighting. It seems straightforward, but it's not. Avoid dark backgrounds, avoid windows in the background. Exactly the opposite of my background, basically. Avoid bright light on the face. For the audio, we've noticed that audio can be a huge issue in many instances. So make sure to have good audio so you can record yourself and listen back to see and make sure you have good audio. Record the audio directly on your computer to avoid issues with bandwidth. Make sure there is no background noise. Dogs are very common background noise. For the text, write a script, practice, speak slowly and clearly, and add caption in case the audio is not clear. This can happen sometimes, especially if you're in a room. And show enthusiasm when you talk. I should add that one as well. Shine. So don't be shy to work on some video edition software. Show it to colleagues for validation and share. So we're going to show you 2 videos made by Claire, which volunteered to be our guinea pig today. And she, there will be 2 videos, short video examples. One is really of poor quality and content, and the other one is a much better quality and content. And we're going to see if you can spot the difference and take some time to discuss about it, and share general feedback with the group. So the first one.
Just to give you an overview of the technologies available in the facility, we have a lot of really advanced light microscopes available for use. We have 2 Axio Observer inverted wide field microscopes, 2 LSM 710 confocal laser scanning microscopes, and one has spectral imaging. We have 1 LSM 800 confocal laser scanning microscope, a total internal reflection fluorescence microscope, fluorescence lifetime imaging microscopy, raster image correlation spectroscopy, spinning disk confocal microscopy with metamorph hardware control, image express micro high content screening microscopy, lattice light sheet microscopy, live imaging, and Fiji Image J and Amaris software.
Okay, so now we're going to watch the second one.
So today I'd like to tell you about the Advanced Bioimaging Facility. We have many advanced techniques available at the facility, including live cell imaging. In this movie, you can see 3-color live cell imaging as cells crawl across the surface. And we have nuclear staining, staining of adhesions, and staining of the mitochondria. We also have polarization microscopy, where you can look at, in this case, breast cancer. And this is tumor tissue showing different types of collagen, which show up in the polarization microscopy as green and orangish colors, depending on their molecular structure. We can do quantitative dynamic imaging, in this case showing adhesion structures using total internal reflection fluorescence microscopy. And these images can be used to segment, track, and measure intensity and dynamics of these structures over time. We can also do 7-color imaging, here showing multiple markers in breast cancer tissue. And we have access and expertise with 3D Amaris image analysis software. This example shows a cyst of cells. The cyan is showing the nucleus of each cell, the green are the cell membranes, and the magenta is the mitochondria.
So I guess I cut it at the right place. Claire, let me know if I made a mistake. Oops. So
Hello.
Any comments? What can we say about those videos?